Hello, and welcome to this week's edition of Forestry Fridays. My name is Noah Schaeffer. I'm a forest stewardship specialist with the North Dakota Forest Service out of our Lisbon field office. Today, we'll discuss some of the common issues that may be found within windbreaks across our area. Let's get started with something that many of us are unfortunately all too familiar with, Dutch elm disease. The fungi have been spreading across North America since the 1920s and have killed most of the native elms in the United States over the past century. Closer to home, Dutch elm disease has been affecting elms since about 1970. It was first detected in Mandan and quickly spread. American elm and Siberian elm are both found within windbreaks across much of the state, and they are both susceptible to Dutch elm disease at varying levels. American elm were favored in windbreaks back in the day because of their tendency to grow quickly on a variety of sites along with a nice shape. Unfortunately, today, those elm may look like the center of the picture on the right, a sparse row of stumps and snags. The first symptom of Dutch elm disease is yellowing of foliage, followed by wilting, browning, and early defoliation. These symptoms progress downward from the point of infection to all lower branches and eventually the main trunk and root system. The entire tree will finally wilt and die. Dutch elm disease affects the xylem of trees and thus restricts water movement. Although today many of our native elm have been lost to Dutch elm disease, there are certainly still some on the landscape, and observing a healthy American elm is always a treat. In your landscaping, remember no elm is completely immune to Dutch elm disease. The variety of cultivars available today just vary in their resistance to the disease. Black knot is another rather common issue within and around windbreaks. This affects our prunus species, including chokecherry and plum. The fungus produces woody swellings or knots on twigs, branches, and small stems. On large branches and stems, infections can result in cankerous galls, rough bark, or even both. Knots become greenish and soft in late spring, about 1 year after infection, but over time become black and hard. Severely infected trees can have very little value due to their physical and aesthetic effects. Heavy black knot infections can significantly reduce plant vigor and fruit production. Older branches beyond knots frequently die. New branches beyond knots often do not develop new shoots, or if they do, they may leaf out and wilt. Pruning can be done to reduce the damage. It is best to prune in the winter or early spring while the branches are bare. It makes it easier to see the infected areas. Keeping your tools clean and properly disposing of pruned material and checking up the following year are all important to a successful pruning treatment. Needle casts of spruce is another issue that can be noticed within windbreaks. There are two types of needle cast diseases that affect our spruce trees. Today, we're not going to get into the specifics of each one individually. However, I will mention that Rhizosphaera and Stigmina needle casts are the two that are referenced today. Typically, spruce will have at least 4 age classes of needles. Older needles may naturally be shaded and cast, and with these two diseases, there is premature needle loss. With both of them, they start low and interior where the conditions are right and progress up and out. It may first appear on the north, which is typically the shaded side, or it may even pop up on the wind protected side where conditions are more favorable. This develops when the right moisture and temperature conditions exist. If you suspect you may be dealing with needle cast, you can use a small hand lens to look for small, dark brown or black spherical fruiting bodies that emerge through the stomata of the spring after infection. Branches with insufficient healthy needles may die, which in turn may affect their performance in the windbreak setting. As mentioned, this is moisture dependent, and a couple dry years keep it at bay, while a few wet years may cause severe needle cast. Early identification helps avoid major damage, as this can be reduced through fungicides and pruning. Weed barrier fabrics have become popular and have shown to be effective in reducing weeds during windbreak establishment. Theoretically, these products should provide weed control for a few years, allowing for tree establishment, and then we assume that the fabric will break down. A common factor of all the pictures you see is the presence of fabric, believe it or not. Successfully establishing trees may require many hours of labor, whether it's watering, weeding, replacing, but we can't forget about the fabric. We will need routine maintenance on the fabric as well. Although we assume that the fabric should break down over time, this does not always happen, and weed barrier fabric may girdle, otherwise known as choke, your trees. Fabric is a great way to manage weeds while establishing trees. It is low maintenance and assists greatly with tree establishment and growth. However, low maintenance does not mean no maintenance. We want to avoid what's in the pictures. Fabrics break down fairly slow in our drier climate. To prevent this, annually inspect your trees after snowmelt and before tree growth. As needed, you should create relief cuts with a utility knife on 2 or 4 sides of the tree. Care should be taken to avoid damaging the tree. If the tree becomes girdled by the fabric or even other tree roots, it doesn't have room to grow, and the tree will suffer limited growth and may even die. A tree that becomes stressed due to girdling can grow around the fabric edge. This creates instability or a weakness in the trunk that can result in premature death from winds and imbalanced weight. Stem decay is the decay of wood and above ground stems of live trees. Various fungi cause stem decays in our areas. The conchs, or what you might know as mushrooms, are often the first outward evidence of infection, but they only appear years after decay begins, and they may never appear, even when the tree is extensively decayed. Crown symptoms are not a common factor with stem decay, but they can occur. Decay in stems and branches increases the likelihood of mechanical failure. This is often present in green ash. There are numerous types of powdery mildew across the landscape. The fungi are host-specific, with some species that can be affected, including buckeyes, oaks, and what we'll focus on today are the lilacs. Common lilac are the most susceptible of all the lilacs. Colonies of powdery mildew develop in late summer, and by fall, whole leaves can be covered. Leaves can wilt if they are severely covered. If the disease does not appear until late summer, there is little concern that it will seriously harm the individual. If the disease begins to develop earlier in the season, the infection may result in reduced growth. The disease cycle requires different environmental conditions for spore formation and dispersal. It develops best with cool, humid nights and warm, dry days. Thus why we see it in late summer or fall in our area. This is rarely fatal to lilacs. Most often it becomes a concern due to the aesthetics that it brings. Chlorosis is the yellowing of plant leaves due to a deficiency in iron. Trees grown in alkaline soils present the greatest risk. Iron in most cases is still available. However, in alkaline situations, the iron in the soil is not able to be used by the tree. The issue is most often linked to iron deficiencies, but it is a complex issue that involves a number of problems. The production of chlorophyll is dependent on iron, and the lack of chlorophyll leads to discoloration. Trees with severe chlorosis typically decline and die over several years. Chlorosis is difficult to correct. As mentioned earlier, there are several factors that may be contributing to the chlorotic condition. Primarily, this is an issue with our maple species. And in your landscaping, remember it is a complex issue, and the treatments that are available to you on the market today may or may not work for you. Now let's move into something that maybe we should keep our eyes open for or be aware of. Now we've all heard about emerald ash borer, but who knows when it'll show up in North Dakota. It was first detected in 2002 in Michigan, and since then it has been confirmed in South Dakota, Minnesota, and Manitoba, and many other states, but those three are just our direct neighbors, with one of them being in Canada. This kills all North American ash species. The damage comes from the larvae feeding on the phloem, which limits or restricts nutrient transport. And you will likely never see the adult beetle, but woodpeckers can help you detect emerald ash borer as they are attracted to infested trees. Now with that said, that does not mean every tree or every ash tree with a woodpecker on it has emerald ash borer. Infestations likely won't be noticed until it has been infected for 2 or 3 years. Moving into something maybe some of us aren't as familiar with is pine wilt. It is another issue to be aware of. It is spread by the interaction of the pine wilt nematode and the pine sawyer beetles. The disease has caused extensive damage to exotic pines, especially Scots pine. It is expanding north. This is already a major issue in South Dakota. This primarily affects mature trees and plantings in windbreaks. A tree can be killed within a few weeks. And thinking, what can we do about it? Alternating Scots and Ponderosa within a row may be a good insurance policy that we have available to us today. For more information and other issues, this document, Diseases of Trees in the Great Plains, is a great resource. Thank you for tuning in to this week's edition of Forestry Fridays. As always, for more information on trees and forest management, visit our website and follow us on Facebook and Instagram.